Welcome back to the channel. This is the Earth Science Classroom. This video is on hydrology and river dynamics, and we're looking at how does a river meander? How does it change course, in which section of the river, and what are the fundamental parameters to allow a river to do this and change course and snake its way across the landscape. This is the Earth Science Classroom. The term meander or meandering refers to a river's flow downslope that deviates from a straight line path and begins to curve, bend, and wander across the landscape. And this word meander comes from an ancient Greek word meandros, which refers to a single river in Turkey which has that classic meander shape in which the word or term comes from. A river is a dynamic system, and to create a meander within a river system at a certain location along the course of the river, you would need certain factors to create this meander. And these factors are in three main divisions or three main sectors or types. You have geological factors, which include the channel slope and gradient, how steep the river is. That will relate to the type of flow, laminar or turbulent, and also the velocity and the ability for the river to erode the channel and riverbed. Then you have the bank material, the type of sediment or rock that the river banks are made of, which is then linked to the erodibility of that bank, because the meander is going to migrate and move. Thus, you're going to have large amounts of erosion in certain areas of the meander. Then you have the water factors itself. So the river itself, the discharge, the amount of water flowing down the channel at one time. You have the speed of that water, and you have the amount of sediment and dissolved load and material that the river is carrying or transporting, which will then lead to the ability for the water or river to erode. And this links to the degree or amount of erosion the river will do as it flows down through the meander. Then you have the biological factors. So the human factors would be the artificial or change in the river, which is called channeling, and then also the amount and cover and type of vegetation. So the riparian zone, the vegetation along the banks, which would then dictate the strength and erodibility of that bank, which again links back to the gradient and the discharge and the sediment load. So all these factors play an important role in combining at a certain amount or level all together to create an environment or a landscape which would allow a river to meander. The formation of a meander occurs in certain stages and phases. The first would be a just straight river with a sinuosity of 1, which is the index or level or degree of path deviation from a straight line. So 1 would be a straight line. Anything that has a meander would be over 1 or greater than 1. So it's a straight river channel with either laminar flow or turbulent flow, and you have a certain erosion and deposition ratio, more erosion, and the sediment load would be based on the environment, the geology, and the discharge and velocity levels of that river. Here we have a channel profile from point A to point B along the straight line river, and prior to any meandering you have this uniform, more symmetrical river channel profile. The Thalweg is located in the center of the river, the deepest part, also the fastest moving water, and you have a very even slope and riverbed on either side, denoting a straight line river with uniform velocity, with a uniform erosion and deposition ratio based on the stream's velocity. Moving on from stage 1, a straight line river channel, you have certain factors that change, which will start to influence the river to create a meander. The first change is the location where this happens. This is more in the middle section or the transition section of the river system, whereby two things happen which are influential in forming a meander. The first is the change in the river's gradient, the course gradient, the topography, the landscape, the relief changes from a high elevation, high gradient, high velocity channel to a slower, more gentle, more flatter terrain, which would decrease the gradient and therefore would have an immediate effect on the stream or water's velocity slows down. The discharge will increase, which means there's more water within the actual river channel. The channel is going to become wider, but the main factors are the gradient, and that will cause the river to slow down, which will then change the amount of deposition and erosion the river produces as it flows down this section. This kickstarts the formation of a meander. With a change in the gradient and a change in the velocity, you have a change in the profile. Now, the fastest and deepest part of the river channel is no longer in the center. It is no longer uniformed or symmetrical, but now offset to one side. The Thalweg is to one side, the right side, which denotes the faster moving water, and the deeper part with more erosion and a steeper river cliff. On the left side, the opposite side, you have a slowing down or decreasing velocity due to the increased friction between the water and riverbed and the change in the shape of that side of the channel bed. So you have a distinct difference and change between a straight line channel and that channel that starts to deviate and starts to curve. In the middle course of the river, you have a change in gradient where it gets less steep, and you have the change in velocity of the water. The flow is going to slow down. This will change everything. Once the water slows down in certain areas of the channel of the river, you get more deposition. The drop-in of any load that is being carried by the river. So any material, any sediment that's unconsolidated, any silt, any clay, any pebbles, stones, rocks, you name it, based on the size and the energy and what's being removed from the upper course and being transported down, that will be deposited when the water slows down. Now, when it starts to bend, you get the change and modification of where the faster part of the river is on one side, compared to being in the middle on more of a straight line channel. This curved channel, this bending of the river, creates a migration of where the fast moving water is versus the slow moving water. The slow moving water will have more deposition. The fast moving water on that part of the channel will have more erosion and will break down more of the riverbank, creating more load, but the slower part will have what's called a lateral bar or point bar that's formed, which is an accumulation of unconsolidated sediment around the convex bend or bank, and this will create this sediment, again diverting the river into the faster sections and the Thalweg. The area or zone of fast moving water will have this larger amount of erosion, and it will start to break down and cut into the side of the river, the bank, and create what's called a river cliff. A steeper bank which would eventually collapse, providing more sediment for the river to flow downstream and also to slowly migrate and move the concave riverbank to a new location. It'll extend the bend further out as the cliff erodes and breaks down, creating the migration of this curve downstream. And you create both riffles and pools within the bend section of the river. Riffles would be the shallow, slower, more turbulent water, and the pool area would be the deeper, faster moving water, usually where you'll find the Thalweg. With this profile of the river, you see on both sides a positive feedback loop, whereby on the slower left side of the channel, with a shallower and slower moving water, you have increased friction, which again slows down the river between the bank and the riverbed and the water itself. That will increase the deposition, which increase the amount of unconsolidated sediment being deposited onto the river bed, forming a lateral bar or point bar, and the increase or accumulation of the sediment will then further the friction and decrease the depth of the river, slowing down the water even further, increasing deposition. On the other side, you have this increased erosion due to the speed of the water, the depth of the water, the pool, the deeper part, the thalweg, and you have less deposition, more erosion. You have the formation of the cliff, and you have the undercutting of the cliff, and because of the deepening of the water and the flow of the water with higher velocity, you have the increased erosion and removal of water, removal of sediment as the weathering erosion continues across this concave bend, and it's going to migrate the bend and increase the bend as this continues over time. So you have two sides of the channel, both with very distinct differences in flow velocity, and characteristics. If you're looking at the river from an aerial perspective, from above, looking at the river's change of course, the meander, you're looking at this flow or snake-like pattern of the river moving downstream, and the extent or the size of the bends or the curves or the meanders are limited or based on the size of the floodplain in terms of how wide it is, in terms of the geology and the sediments, the erodibility, and where the bluff line or the valley wall or the edge of the floodplain begins, because if you have a wide open floodplain, there'll be more opportunity for the river to curve and bend and meander within this larger floodplain. And you can see the previous course of the river shown with this blue dashed line and the migration of these meanders over time as the concave river cliffs become weathered and eroded and move and extend the bend. And you also see the location of prior or previous lateral deposits and point bars, and you have the pattern emerging on the river bends where you have the erosion, which is the E letter, and the deposition, which is shown by the D. So you have this change in course creating a convex bend and a concave bend, and there you'll find either the erosion or the deposition, and you'll find that the flow of the river, the thalweg, the faster, deeper parts of the river, will be in certain areas linked to the erosion. And the wavelength of the meander is the distance between the two bends, or the two areas where the river bends and curves and changes direction. So the wavelength can extend or decrease based on the topography and based on the geology, and also based on the discharge of the river. So the amount of water flowing down will affect how fast the meander migrates, how far it migrates, and the extent of the bend. Is it a shorter, smaller wavelength, or is it a shorter, smaller bend? Or is it going to do the opposite, where extend the wavelength, extend this large bend, and perhaps create oxbow lakes? This is all based on the discharge of the river and the amount of water flowing down. What I've discussed on how a river creates a meander and changes its course and migrates and evolves over time is generic, and each river has its own set of characteristics and parameters and factors which will influence the formation and extent of a meander, and each river can change over time based on the flow of water, the climate, the topography changes, and also tectonics. So this is very generic, yet can be very specific based on each individual river. This is the Earth Science Classroom. Thanks for watching the video. If you liked it, please subscribe, like, and share. And if you want more content and videos on Earth Science, please check out my channel.